200, then you're going to try number 3. Let's see if you got 100% or where we still don't understand things. Decreasing. That means from left to right is the graph going up or down and where? Actually going down all the time from left to right. So you could write everywhere. You want to write everywhere. That would be an acceptable answer. You could write negative infinity, positive infinity as an interval. Negative infinity to positive infinity basically means everywhere. We don't really write all real numbers for this one. That's kind of how we write a domain and a range, that x could be all real numbers, but I would also understand if you meant that. All right, the y-intercept, what, 0, 2. How did you do writing the actual coordinates? And then let's see, the x value looks like 4, so I write 4, 0. Okay, f of 2. This is different language than what we used yesterday. Yesterday up top, it says evaluate when x is blah, blah, blah. So I want to know evaluate when x equals 2. Find where you are on the graph when x is 2. What's the y value? Right here. Right? When x is 2, the coordinate is 2, 1. So the answer is the y value should have been 1. So there's a couple different ways that you'll get asked that same question. What's the maximum? How high can I go? Infinity, because the arrow points up over here forever and ever and ever. How low can I go? Pointing down forever and ever and ever. So I write negative infinity. Domain and range for a linear function goes forever and forever. So they're both the boldface capital R, or you can write all real numbers. I can go left and right, up and down forever. Can you write the equation of this function from unit 1? What's the equation? What's the slope and what's the y-intercept? So maybe try a slope triangle. If I start from the y-intercept, what's my slope? Down 1 over 2. So my slope is negative 1/2. Make sure you write x. And what's my y-intercept? So don't forget how to do unit 1 now that we're out of unit 1. So, and we said some of us still need practice graphing, converting the equation, doing substitution elimination. So we'll try to do a little bit of that algebra every day. So what of those questions do we still need help on? I'm guessing domain and range. Did you know how to do every other question? Good. So now try, if you haven't had a chance, I'd like to look at the back page using this graph vocabulary on this application problem. Here's like a real world, science graph that you're analyzing about tadpoles. So think about population in a pond, what's happening over time to this tadpole population. So try it on your own first if you haven't. And more importantly, what does it represent in this problem? What did you estimate the y-intercept was? What? Yeah, 200. Or 0, 200 if you wanted to. What does it represent? In the year, what? So in 1990, right, the y-intercept tells us there were 200 tadpoles. That's what it's telling me, right? Okay, what was the maximum number of tadpoles to live in the pond? When did it occur? What did you estimate this value was? What'd you say? Yeah, 1,500? It's below 16. So, did you say 18? Okay, so yeah, so it's about 1,500 in year 1992, right? 1,500 tadpoles in 1992. What's the local minimum? So do you see how this value right here is a local minimum? The population was lower at the beginning, but something happened here that caused the population to plummet. Maybe there was chemicals in the pond. I don't know, maybe it was a harsh winter and it killed them off. But then here, that was the lowest it got, and then it started, something happened, it rebounded a little bit. So the local minimum was what? I don't know, did you say 300 or 350? Yeah, about like 300 tadpoles in what, 1993. Is the graph increasing or decreasing beyond 1997? Yeah, so I would say looks like the population of tadpoles is decreasing if the trend continues. So see how you're using the vocabulary to actually analyze a situation? What was the rate of change between 1990 and 1992? So you think about what was your rise and what was your run. So if I'm going from 200, what did we call this? 1500? What was my rise then? 1300 tadpoles would be my rise over 2 years, right? So 650? Or did you say 700? What'd you say? Or you didn't know how to do it, but it's the rise over the run. So I would say if I called this 200 and I called this 1500, 1300 tadpoles over 2 years, 650 tadpoles per year. And we struggled with this type of problem on the unit test. What is the y-intercept and what does it represent? So that's going to keep coming up in this unit to hopefully make you stronger at communicating, looking at the graph and what does it mean and what does the maximum mean, that kind of thing. Okay, so I'd like you to turn back to our resource page on parent functions. Some of these will be brand new to you. I want you to be able to, this is resource page 2. I want you to be able to look at data. I think we already know if it's linear. Now we have to decide what other type of function might we be looking at. We're focusing on quadratics, but this introduces you to this family of all these functions. All right, so the first one we're going to look at is a linear function. I'm going to write y equals mx plus b because that's what we called it last unit. Now we're just saying that the parent function is y equals x, or f of x equals x. Everybody see where this is, the resource page, second one? All right, how do I graph a linear function? This just parent function is a slope of 1 through the origin, right? Because it's the line y equals x. That should be a straight line through the origin. And our new kind of concept is, what's the domain and range for a linear function? I can open up both left and right forever and up and down forever. So both my domain and range are all real numbers. Let me show you one exception. Does anybody know from geometry? You don't have to write this down. Does anybody know from geometry what that is called? That's not a line. That's a ray. Does a ray go forever in both directions? No. So its domain is not going to be all real numbers. It might have a domain that starts like at 1 and x is greater than or equal to 1. It might have a range that starts at 2 and y has to be greater than or equal to 2. So just because it's linear doesn't mean the domain and range has to be all real numbers if it's a ray. So that's something to look out for, but this, if it's arrows in both directions, you're good. Okay, a quadratic function. We're going to learn a lot about this function, this unit. Y equals x squared is this U-shaped graph coming out of the origin right there. That's the vertex at 0, 0. So you want to be able to recognize this is linear data versus quadratic data. It also might be quadratic if it's upside down. That is the same curve, just shifted or flipped. It always has a domain of all real numbers. Side to side, the U shape stretches bigger and bigger, but it's going to depend where the bottom or the top of your parabola is. It'll change your range. The parent function is y is greater than or equal to 0. We're going to move it all around. So if it was down, if it was like down here, the range might be y is greater than or equal to -2, because it's starting here and it's going up. So you're going to have to look and see where the graph starts. All right, the next one. You might not have ever looked at a cubic function before, x cubed, but it looks like this. So the reason it looks like this, if I made a quick table of values at like -1, 0, and 1, -1 cubed, -1 times -1 times -1 is -1. And 0 cubed is 0, and 1 cubed is 1. And then it gets really steep because 2 cubed is 8, and 3 cubed is 27. So it's kind of an S-shaped curve that gets really steep really fast. It also might be cubic. So I guess I should write over here, like with quadratic, you might see an upside down U-shaped graph. That's still quadratic, even if it's upside down. A cubic function, you might see the more exaggerated bumps. That's also a cubic function. It's just not a parent graph. Nothing has happened to a parent graph, and a lot has happened. Like this might be the function, x cubed plus 2x squared plus 3x plus 7, and it has like these exaggerated curves. It's still considered a cubic function. So then domain and range for this one is also all real numbers, because I have arrows that go up and down and side to side forever. So if you look at these 3 graphs look really different from each other. So like your quiz question is just going to be, if I show you a picture of this, do you know that's quadratic? If I show you a picture of that, do you know that that is linear? Starting to memorize what the shapes of these curves look like. Square root is a lot different looking. You might have never seen the square root curve. Basically, it looks like half of a sideways parabola. Because can I take the square root of a negative number? So there's no graph over on this side of the axis. And then if you go over, the square root of 25 is only 5, right? The square root of 16 is only 4. So you're going a long ways and you're creeping up very slowly. So it's a sideways parabola, but it's only half of a sideways parabola. Its domain, x has to be greater than or equal to 0. Because if I try to take the square root of like -4, it won't let me do that. So I can only take the square root of 0 to the right, and a square root function always produces a positive outcome. So all of my y values are in the first quadrant. They're never negative. So do you think these look kind of different from each other? So you have to be able to pick the correct model for the data. We don't know a whole lot about cubic and square root just yet. So right now we're just looking at the data and deciding the type of function. Can I move to the other page? Okay, here are 4 more functions that I want you to just recognize. We're going to spend an entire unit on exponential. So right now you're just identifying, oh, that's exponential. I'm going to write 2 to the x power for increasing. And I'm going to kind of draw a curve that looks like this. But it could also be 3 to the x or 10 to the x. It doesn't matter what the base is, as long as it's a number bigger than 1. Exponential decreasing is when like your population is decreasing over time. And that's when you have a base that's like a fraction. 1/3 to the x, 1/10 to the x. So this should be like, oh, my money is doubling every year. Or the population of bunnies is doubling every day. This would be, oh, my bacteria are dying. So I only have half as much each day because I'm on a medication or something. So like the population is coming down exponentially. I want you to know that the domain, you can plug anything you want in, but your range will always stay over the x-axis. If I'm going from here to the door and I'm cutting my distance in half each time, so now I'm halfway closer to the door, now I'm halfway closer to the door, am I ever going to actually get to the door? If I'm cutting it in half every time, I mean, technically you're going to be like, 0.000 millimeters away. Technically you can cut that in half. So now you're like fairly closer, but you're never going to be negative. Like I'm never going to be past the door if I'm cutting my distance in half. So that's You're doubling it this direction, you're cutting it in half this direction. You're never going to get there. All right, and then the last two, we're going to see absolute value a lot this unit. Does anybody remember this absolute value symbol from Algebra 1 or pre-algebra? If I told you I was looking for the absolute value of 7, what's the absolute value of 7 equal to? 7, because it's the distance from 0. So what's the absolute value of -7? Also 7. So on a number line, I'm either 7 steps in this direction or 7 steps in this direction. How far am I from 0? I'm 7 away from 0. This graph we're going to study in detail. Basically, it makes, 1 is always 1, 2 is always 2, 3 is always 3. What happens when my line comes down into the negatives? It just makes the positive distance. Right, so at -7, my distance is 7. At -3, my distance is 3. So it makes a V-shaped graph. So how can you tell the difference between a quadratic and an absolute value? Sharp curve versus a U-shape. So knowing the difference between those two is important. We're going to look at this one in detail in a later set of notes, but knowing that the domain is all real numbers, my arrows go forever side to side. Does anyone want to take a shot at the range? Can I go below? No. Can I be 0? Can I take the absolute value of 0? Yeah, I would just be sitting at 0, right? So 0. So y has to be greater than or equal to 0. People who weren't here yesterday, I gave the hint. If you ever forget what domain is, it goes with X because it's alphabetical order. If you ever forget what range goes with, it goes with Y. And our coordinate always goes X, comma, Y. So everything's in alphabetical order for you to remember. Okay, and the last one before lunch, cube root. This is a symbol you might not have seen very much, a cube root. The index is a 3. Does anybody know any perfect cubes? What's 2 cubed? Now 2 times 2 times 2 is how much? So 2 cubed is 8. What's 3 cubed? 27. What's 4 cubed? That's another important one. 4 times 4 times 4 is 64. So those values end up shaping this graph as a sideways cube root function. So it looks like an S-shaped graph through the origin, because remember our cube function looks like this through the origin. So it's basically taking like the point 2, 8 is now becoming 8, 2. It's flipping the cube, x cubed, on its side. And its domain and range are all real numbers. So now that I've given you kind of a rundown of the 8 parent functions, after lunch, when you come back, we'll do the warm-up of now match the parent function and see if you can figure out the domain and range. Cubed. So from up here, you're going to pick which of these graphs is the x cubed graph. What would I put for number 1? This is page 202, part 1. We're skipping 201 for C then. Yeah, keep going. Right there. So page 202. This is page 202. I'm skipping to this parent function, domain and range practice. We're just looking at practice part 1, and then I want to have you do a little calculator activity. The cube function is which one? No. X cubed. It's B. So under number 1, graph B is the answer. So you write the graph down below, and then what is the name of it? N. It's a cube function or cubic function. So number 1 is B and the letter N. Does it kind of make sense how you're going to match them up? So it's kind of a quick check of what we did before lunch. We'll do another one tomorrow, practice part 2 tomorrow, just to keep hitting it. And then we'll do practice part 3 when we get back from vacation. Yeah. Well, there's one that's close to that. No. Look at this one again. Oh, yeah. You guys see where we are? 202. You're just kind of matching that. Try to do it without looking back and forth and see if you can match them up. It's just multiple choice. Just a quick practice, and then I'm going to show you how I want you to do the calculator part. So that means everybody needs a calculator. Because that's there. You have one, right? You have one. Is there a calculator in your bed? Is there a calculator in your bed? Okay. What about your calculator? I'm gonna have to. You need one, right? I mean, what do you need one for? We don't need it for today. You don't have calculator. Oh, the calculator. Oh, here's two. So you need one for the fruit. You have one. You have one. Do you need one? Because in a minute we're going to be typing in some equations and doing an exploration of what does this do to the graph? One. What these do? You need one? You need one. You need one? Did you need one, Aiden? Okay. The rest of them have dinosaur board. You have a. You'll still need a calculator. Type in the equations. You all have one now? Well, you can type them in here. Look and see what they look like. No one else needs a calculator? I'll give you one now. Can you use it as long as it lasts? Okay. So I'll give you 1 minute to match those up. I wanted to give you the homework packet because our first one is due tomorrow, and you're plotting points on the graph and deciding is it linear, quadratic, absolute value. It's only 4 questions. So I'm going to give you the homework packet so you can try for 2-1 for tomorrow. I think it will only take you about 10 minutes or less. You can either do it in flex tomorrow if you wanted to. So that's the only thing due before vacation, and then the rest of the packet is after vacation. So just 2-1, you're going to do for tomorrow. You plot the scatter plot, and then you decide if it's linear, exponential, quadratic, cubic, one of those. Yeah, wait, where is it? 0.145. So it's very close to the x-axis. Graph it as close to the x-axis as you can. Did everyone get a homework packet? Oh, that's done now? Can you ask me tomorrow what you got on it? So I remember to tell you. Tomorrow. 2.1 is due tomorrow. It's 4 scatter plots, and you're saying what type of function it is. Should we go over the answers, or are you still matching them up? I'll wait like 1 more minute. You're supposed to be thinking in your own head which one first. You can't match them up? Oh, you're almost done. 1 left, 2 left, right? Well, hopefully if you do this for 3 days, today, tomorrow, and Monday, parent names and what they look like. Okay. All right, let's say the answers, and then I'll have you do some graphics. You don't see it on there? 1, 2, 3, 4, 5, 6, 7. I have 7 of each, don't I? Let's see. Number 2 is the square root graph, so that should have been F. and square root function m, fm. Do we get that one? 2 to the x is exponential, so that was graph D and L, DL. X squared is the C graph, and it's a quadratic function I. Well, I'm just going in order. Number 5, X is graph A, and that's called linear, right? Oh, so they can call it identity when it goes through the origin, but identity and linear function are just kind of two ways to say the same thing when it's through the origin. So that one I won't call it identity. I'll call it linear. This is what cube root is graph G, and cube root was H. Absolute value is the V-shaped graph, so that was E and J. So does it make sense what our goal is? Our goal is to be able to recognize the function and name it. So we talked about graph vocabulary, max and min, domain range, increasing, decreasing, those words. And then this is kind of part 2 of your quiz, the Wednesday we get back. So like naming them, identifying them. And then domain and range, we still need to practice. Okay, so the third part of your quiz, we're just going to do an exploration on today, which means like, let's think about what's happening to each of these graphs. So go to the 201 transformation exploration for quadratics and absolute value. I'm going to show you how to start number 1 on each page. And then that way you can go through 2 through, this is page 201, sorry. It was right in between what we were doing. So 201. I listed all the steps up at the top, but I'm just going to do number 1 with you, and then you can go through and do the rest of like the quadratics, and I'll do number 1 on the next page with you, or say number 9. Okay, so get out your calculator. We want to first graph this parent function. So go to your y equals menu. So y equals, does everybody have this up? You don't want to have your scatter plot turned on, so none of your plots should be bold. And we're just going to type in x squared. So the x key is next to alpha and then squared. This is the parent function. So we're going to keep this in this slot for all of the other examples. Now I want you to hit zoom 6 and make sure that your parabola shows up. So that is already on each of these graphs. Did anyone need help getting their quadratic to show up? You got it on there? Zoom 6. Right, so this is the parent function. We want to compare x squared plus 1 to the parent function. So you're going to go back to your y equals menu, arrow down, and in y2, you're going to type x squared plus 1 so that you can see it as a different graph. Now that you've hit zoom 6, you can just hit graph every time, the top right corner of your calculator. So there was my original. Yours shows up as blue and red. So the original was here. What happened to the red graph? It went up 1. So on your paper, you're just going to show that this is now a quadratic like this that went up 1. So you're going to sketch what your new graph looks like. So it's up 1, and you're going to write it in words up 1. Does that kind of make sense? Yeah. Then you'll go back and do number 2 and change the function to x squared minus 3. So maybe why don't I leave you to do that part first, and then when you get to the second part in its absolute value, I can just show individuals how to type that part in. That way you're cruising on the quadratics for 1 through 8. Does that make sense? So go through and do 1 through 8. The next one should hopefully shift it down 3. So make sure when you type the next one in, you're using the minus key, not the negative key, right? The big minus. So it should show your original and then show that your next equation went down 3. Did everybody get it to work for number 2 on their own? Okay, so that's it. We're just seeing like, okay, maybe by the next page you can start predicting what do you think is going to happen. Like this went down 3. Okay, so we're going to talk about the different graphs, but we did all the way through number 19.